Hi guys, welcome back to my channel Programming with Pirai. In this video, we are going to solve electro question number 367, valid perfect square. If you already solved a square root of x, it is a similar problem. Okay, there we will return the nearest, that is the floor value of square root of x. But here we are going to return the true or false. Let's see this question. Given a positive integer num, return true if num is perfect square, otherwise return false. Okay, we want to return whether it is perfect square, and we don't want to do it using the built-in libraries. Okay. So let us assume this examples. See here, num is equal to 16. Okay, so 16 can be written as 4 into 4, so it is a perfect square. Yes, so it's a perfect square, right? Because it is an integer. Yes, again 14 can be written as 3.742 square. Okay, but this is not an integer, so this you return false. Okay, so this is what a problem statement. But how can you do this? Okay, the simpler way is, just see here, it is 16, right? Now 1 square is equal to 1. Initially 0 square, 0 square is equal to 0. 1 square is equal to 1. 2 square is equal to 2, sorry, 4. 3 square is equal to 9, and then 4 square is equal to 16. We got 16 as an answer, right? Right, stop there, stop there, and then return it, right? And return what? True. Yes, so this is for the first example. Now for second example, see here, 0 square is equal to 0, and then 1 square is equal to 1, 2 square is equal to 4, and then 3 square is equal to 9, and then 4 square is equal to 16. So 16 is greater than 14. It is greater than 14, but still we don't got any number is 14. So return false. So this is the basic approach. So what is time complexity? I can say time complexity is square root of x, right? Square root of x. Why? Because we are going up to what? Square root of x. Square root of 14 is what? 3 point something. So when we are making it as round, it will be what? 4. Okay. Now what is space complexity? It is over 1 because we haven't used any space. So this is the first approach. Okay. Can we optimize it? Let's think about it. Uh, just observe carefully. I can also write this as, just say 0, 1, 4, 9, 16, and then 25, and then maybe what, 36, 49, and then 64, 81, 100. Yes. So this was the square of the numbers from 0 to 10. Yes. Yes. Now let's observe carefully. Okay. Now if I give a target as 9, let us take a target is 9. Now how can we do this in binary search approach? If the target is 9, how can I do this in binary search approach? I will take this as my low pointer and this is my high pointer, right? Right. Now I'm going to check whether the midpoint. Okay. First of all, we are going to check the midpoint. The midpoint is here. It's 5. Okay. Now 25 is greater than 9. No, it is less than 9. Yes. Sorry. 25 is greater than 9, right? 25 is greater than 9. So if we go along this way, whether there is any 9 would be there. No, no. This is a basic binary search approach. Okay, no. So we will move towards the side. So shift for upper binder here. Now again, this may mid binder. This way mid binder. Now whether mid binder is equal to 9? No, no, no. So it is less than 9. So this part cannot be my answer. Yes. So I will move here. Now again mid. So here is mid. It is 9 now. Return it. Return what? True. That's all. Understand? Understand? If we done everything, we have done everything. Just take for example, if it is 10. If it is 10, then we don't return it, right? We will move our low pointer here. Yes. And then again, we will check for 16. Whether 16 is equal to 10. No. It is greater than 10. So we move this upper limit to here. Now upper limit is less than lower limit. So we will terminate the loop. So if we terminate the loop successfully, then we want to return what? False, because we didn't have any such numbers in our perfect square, right? So how to do this? How to do this? We have done a simple binary search here, simple binary search, but still there is only one thing we have done. What's that? In binary search, we have done what? Mid into mid. We are checking the mid into mid. That means just see here, 0 into 0, 1 into 1, 2 into 2, 3 into 3, 4 into 4, 5 into 5, like that. Okay. If I show you the code, it will be more clear. Just see here. Yes, see here. L comma u is equal to 0 comma num. We don't want any array. We just do using what? Just a two pointer and the two values. That's it. We don't want an auxiliary space. Okay, it will be considered as space complexity. Okay. Now while L is less than or equal to u, mid is equal to, I'm just finding the mid pointer. Sorry, mid value. Then if mid value into mid value is equal to num, then I found out the value, right? So I will return what? True. Otherwise, if it is less than, what we will do in binary search, we will move towards right side. That's what I have done here. Else we do what? We do move the upper limit towards the left side. That's what I have done. Okay. So if this is executed successfully, then I will return what? False. That's it. Let me submit it. So this is a basic binary search approach. Okay. In basic binary search approach, we just implemented what? Mid into mid. We just check for num of mid in binary search. But in this problem, we just did mid into mid to find the perfect square. That's it. So what is the time complexity of this solution? It is what? Log n base 2. So time complexity. It is wow, log n base 2. And then what is space complexity? It is warp 1, because we haven't used any auxiliary space. Now we have got a square root of n for brute force, and we have got a log n base 2 for binary search approach, which is efficient. See here, take for example 10,000. 10,000. If I do log n base 2, what is my answer? It will be 13 point something, approximately 14. Okay. Now if we do this 10,000 using square root, what is my value? It is 100, right? It's 100. 14 and 100 gives a vast difference, right? So this binary search approach. This binary search approach is what? Optimal. Optimal. Okay. Understand? Thank you.